Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. This is episode 71, and just like oh, whoops, that's compressor code. uh, this is episode 71, where I hope to make some more progress on the serialization stuff for Rust Boy. We've been making some decent progress last few weeks. Not terribly much stuff, but there's a lot of stuff to get through, so any progress is good progress. Let me close a lot of this stuff. Where were we? Here. I really need to get better at this. Starting this whole stream thing. I never learn. Move around some windows. Okay. So I think where we left off is we ended up refactoring a bunch of stuff, like how the ROM and the SRAM were saved in memory. We removed some data hiding, made some stuff public, removed some kind of redundant methods after that was done. I just kind of decided on this philosophy where like everything, including all internal state in the emulator code, should actually be public, even if that means it's possible for something that bootstraps the emulator to totally ruin its internal workings and make things inconsistent and make things bad. We're probably okay doing that. The main thing is, at least for getting data out, like debuggers and stuff, they really should have as much access to this stuff as possible. And for stuff like serialization, which is what we're doing, it also makes that a lot easier to just operate on the data directly. And I imagine also like maybe there's some kind of cheat thing or task tool that we want to make at some point that will also just want to have all of this state available. Additionally, we did some stuff where we don't have reallocations now for the like WRAM or SRAM whenever we load a save state, or at least that's the idea. I know at least for the Libretro front end, the front end will actually ask us for pointers to the actual data and like VRAM as well. We fixed that I think. If not, we'll do that today. But yeah, it asks for pointers to those, and I guess also so that the Libretro front end can have easy access to that for, again, like cheats or debugging capabilities or whatever. So being able to support that is also really nice. Anyway, it just makes things overall a lot simpler, so I'm pretty happy with that choice, even though we ended up having to change some code last week to support that. I think that's okay. So yeah, we'll just continue with that. I've got a lot of state to get through here, so I'll just continue doing that. I'm gonna put on some music because, again, this stuff is gonna be kind of boring, but we just got to get through it. So I'm kind of excited for this to be done. Anyway, without further ado, I'll just get in. Except I need to say hi to people in the chat. Jono, how's it going? Glad you could finally catch one live. Garrett Kelly, Zakwar, Yana Moran. If I'm saying that wrong, let me know. And Wistertobe, how's it going? So yeah. The nice thing here is that I have another view into this. File, new view. Because we have all of the serialization code here. So it's deserialization in particular that we're working on here. All I really need to do is have the serialization code on this window over here, which you guys can't see, but that's so that, yeah, let me bump up the size too. That'll help. And literally just going line by line and restoring this kind of state. It's boring, but that's what we're doing. Anyway, so now we'll go ahead and work on this. So VB interconnect.vip.vram. I think it's just VRAM is the bytes, so we can do copy from slice state.interconnect.vip.vram is probably what that is. If I remember the version state here. Yeah, VIP state just has it here. Going down the list. I'm going to start inserting some line breaks here just to make this a little easier to see. Kind of matches up a little better with that other code too. We also want to do, in fact, I might even do this. It's kind of obvious, but especially for stuff like the VIP, which is probably going to have a few of these little sections, be nice to have this written out like this. Yeah, vb.interconnect.vip. I could also alias these if I want to, but I think this is going to be okay. Display state is we can match the state.interconnect.vip.display state because these should all be the same names. And then here, state, camera state, gamepad state, interval state, timer state, display state. That sounds stupid, but we're going to go with it. In fact, I might actually want to alias a lot of these types here too, because we pull in like state here. Maybe these don't need to be public in the case of these other aliases. You know, in fact, we probably don't need to alias it anyway, because we'll probably just do version 1 display state, and then we'll have these different ones here. Bam. In fact, we'll do this, and then we could do. This might also need some similar treatment, but then it should just be these same values. Hey, Pyro. Yeah, we're working on restoring the save state stuff. So I've been calling it like deserialization, but at this point, it's really applying the state. The state has already been deserialized. I'm just going to build this really quick to make sure I got that right before I move on. Which terminal is this? Did I close it? I didn't want to close it. I think I did. No, I have it over here. This one, great. Whoops. Probably using the wrong Rust version. The reason I have to change this all the time is when I work on my compressor, I'm doing that in 32-bit. But I'm working in 64-bit on the emulator. Luckily, Rust Up makes this trivial to change. Then we're good. Feels like I've been working on the save state stuff for months, but really it hasn't actually been that long. It's just I haven't touched it for months. Anyway, this built, so that's all I wanted to test. Oh, yeah, I can do cargo check for that, can't I? We talked about this last time, didn't we? Probably use that for this, because it'll be faster. Because a lot of this stuff, like, we can't... It doesn't really make that much sense to test this, like, bit by bit, because we're just restoring a bunch of internal states that if they're not consistent don't really make any sense anyway, so we can't like really test this until it's all there. So just doing check to make sure things compile and we have the right types is kind of the best thing we can do. VB interconnect VIP drawing state is match state dot interconnect dot vip dot drawing state. Same stuff here. This will be drawing state. Check this out. I can do shift and like that. Oh, I like that. Nice. I'm gonna do a lot of these checks as periodically as we go. Just it's easier for me. And yeah, we still have a lot of warnings here. I don't care. I'm gonna care about this, like as we clean stuff up, but as we just kind of want to get everything in place, I don't care. You know, I'm actually thinking as I look at this, we've got a lot of state here still. Like all this stuff. This I just copied from the safe state extraction code. And I think we can do a nice search and replace on this stuff. In fact, technically what we can do here is that. And then this will go well. Just to get all the lines here. That should save us some time. Oh yeah, and all these ones need that too. So let's do this. And this is going to be state interconnect VIP. Okay. I like doing this kind of stuff. Bam. Oh yeah, and then we have all these. All the commas at the end. That's awesome, Pyro. That didn't take long at all. Not that I'm particularly surprised, though, to be honest. Oh, man, you guys, I am getting so stoked to work on the Xenowing again. For those of you guys that don't know, the Xenowing is my late 90s era game console that I'm building on FPGA. I haven't touched it since March, but I've just been thinking more about it, about how I want to architect a lot of it. And I figured out like how I want to run tests on it and how I want the memory allocator to work, all this kind of fun stuff. But I still got to do a lot of stuff with like making sure there's no CPU bugs before I get to any of that. And there's a formal verification test suite that I don't remember who made it. Clifford something? I could find his Twitter. Anyway, this formal verification suite is really nice because the idea is that you implement like a kind of an interface between your hardware and what the tests will expect. I mean, just like you would in software testing, and it'll run a bunch of tests on that on like simulated hardware and make sure everything actually works. Really cool stuff, and I'm really excited to kind of dig back into that. Need to get a few things out of my head first, though. Garrett Kelly says Clifford Wolf. That's absolutely who that is. Awesome looking formal verification test suite, I should say, because I haven't actually tried it, but I'm giving him the benefit of the doubt here. That's probably going to be great. So yeah, I'm pretty stoked about that. Here, we're also going to want to copy from slice, because this is the waveform data in the stuff. This is also going to be VSU. Excuse me. But yeah, I'm really excited to work on that again. It's been burning holes in my brain. I'll do that. One of the reasons I haven't been diving back into that, though, is that I'm still working on my compressor. And because, as I've mentioned a couple times, and I want to do a stream on this too, but I've I've beaten Crunchy, which is like the compressor that everyone uses for 64Ks. I know I'm like way off topic here, but that's I feel like that's half the reason you guys watch these streams anyway. Now I'm getting bad at talking. Anyway, I'm working more on my compressor, and I've beaten Crunchy, but I should say rather I've made a compressor that, while using a lot more CPU and memory than Crunchy, gets better ratios most of the time. And on our particular intros, they get a lot better ratios. Like I think Engage is 2 kilobytes smaller, which is fairly significant at that size. And I know I can get it down to like 2.5K smaller if I just optimize the decompressor more, which is the code you saw at the beginning of the thing. I would really like to do a stream on how a lot of that works, because it's very interesting, and at least I think it is. And I want to get that smaller and get more of that out of my head before I dive too much into another project. But that's been a really long road and a long time coming for me to even get that. And I mean, it should have been possible to do that, to use more CPU, more memory, and get a little bit better ratio. And it was just a matter of me learning enough stuff about compression, which is something I'm not an expert in, to be able to actually do it. And I'm really excited to share those details. So I definitely want to do that on a stream pretty soon. Probably when I get a little smaller and I'm less embarrassed about showing the numbers. Thanks, Garrett Kelly. To be honest, like I feel like that 2K figure is not as good as it could be, and I know I can do better. It turns out that we do most of those gains on the data sections, not on the code sections, and Crunchy, I think, still has better executable modeling than we do. But the compressors are totally different, so it's kind of hard to just start stealing a lot of those ideas. Did I just say hi to her too? I don't remember if I said that or not. Okay, anyway, here in this serialization code, this next part here, I'm just going like line by line here, by the way, so you're not missing much when you don't see me scrolling through this. But I have like these sound ones, because these individual sounds are these standard sound objects, and so I defer to this other function to pull all that state out again. And I'm going to do the exact same thing with apply, because I think if we look at this, we have like this function is get state or whatever. Yeah. And then that defers to all these other get states. And then the function that we're writing now is apply, which is going to apply one of those states back onto a running Virtual Boy instance. And then so I want to also fan out the same way, where this is going to do like a function apply standard sound state. And this is not going to be public. It's just going to be used by this. Hey, Daniel Colin. But yeah, when I say like we get about 2 kilobytes better on Engage, which that actually projects really well, because Engage was 63K with Crunchy and it's 61 with ours, and I know I can get another half a kilobyte off of that. Like it's actually a few hundred bytes below 2K better, but it's not enough to be under the next 512 byte interval, which the file size is aligned by that much, so that's why I'm looking at like final size when I say that metric. But when I like, we don't get that for free, and that's kind of the thing. Like I didn't beat Crunchy because I'm smarter than Rig. That's definitely not the case. It's just I beat it on most intros in my test set by a significant enough amount, and I did that by using a lot more CPU and memory, and using that to kind of taking advantage of that to man, I'm really bad at talking and doing this at the same time. Do and mute this, because I think we'll want to. Yeah, this is the signature we want. That's what we want. Anyway, yeah, it uses a lot more CPU and a lot more memory to implement something that's a bit more general. So it essentially the compressor can see more patterns in more places. Yeah, it's very hard to be smarter than Rick when it comes to lots of stuff. And I think one of the places in my compressor where that's really apparent is the fact that my decompressor is so much larger. I really realized that I'm not very good at x86 assembler when I look at his code and I look at mine, to put it one way. But I'm learning a lot, so it's fun. And it wasn't easy either. Like I mean, you guys know I've been working on that off and on for like 2 years, and only really implemented the schemes that I thought would work really well. Like I thought of that last May, and then I got it working like last week. I'm really excited to do a stream on that, but for now, I want to do this. I think the first thing we'll actually use that for is going to be the music disc that we want to release with the synth. That'll probably be the first thing we release publicly with a packer, and also because I use a lot more CPU and memory, that CPU time scales very much in proportion to the uncompressed size of the intro, or whatever you're compressing. So like, I'll be straight up. Our compressor is useless on a lot of Conspiracy's intros because they're like 1.5 megs uncompressed versus like 200 or 300 kilobytes, which is where a lot of other intros fall. And so that's like a factor of like 5 times bigger. So it compresses like 5 times slower. And since we're already giving up like a few seconds of startup time to be able to compress that much better, that few seconds suddenly translates to enough seconds that you're going to start wondering why no dialog box comes up when you double click the intro. So it's all trade-offs. There's no magic. But yeah, I'm glad you're looking forward to it, Daniel Cullen. I'm really excited to share that stuff. Part of me wants to keep it under wraps just because I know I can do a little bit better. But I should feel more secure in how much fucking work it actually is to do that, because I think there's a reason nobody even tried in like 10 years to beat this thing. I mean, there's a few reasons, let's be fair. One, it's a lot of work, but it's also like, even with our intros, we rarely ever fought for extra bytes. I think in Gauge we did, but that mostly came down to optimizing the music data structures. Dan Collins says, do I plan to open source it? Not right away, at least. And the reason is that I don't want false positives from virus scanners as much as that can be avoided. Although that can't be avoided entirely, and I've already had false positives on executables produced by it just because of the way it's packed. As soon as a lot of antivirus scanners see an executable with one section that has a weird alignment and is read, write, and execute, naturally that is a bit suspicious. Actually, this... we should do this here. So we're not going to get around that entirely, but that's the reason I don't want to open source it. And to be honest, that's the only reason. Oops, this should be apply. Whoops. Dang it. Getting sugar happy here. I was dead tired today, and I just came home and got the best second wind. Now I'm all jittery. Yeah, this seems to be version 1. This 2. Also should be a reference here. And this will give me an error, but this one shouldn't. Oh yeah, these are different ones. Yeah, we'll fan that out in a sec. Telepathy, do you prefer Rust to C++? I do, especially for my personal projects. I mean, I don't mind C++, and I've been doing a lot of C lately anyway. And I still like those, but I generally prefer using Rust. It just feels like there's less to think about, especially when pulling in packages. Nice. These are going quick because I've done all the really boring work on previous streams. Whoops. Oh, I pasted that, didn't I? That's what I did. Copy. Isn't that awesome, Drew, too? Thanks for trying that, by the way. I really appreciate that. Even just people playing around with it. That's awesome. But yeah, that's exactly it. It's just so easy to do that stuff. Oh, nice, Daniel Collin. Did they release firmware updates? Because I thought the SD2 SNES, I knew it had the USB port, but I thought it wasn't implemented. I used the because I have the SD2 SNES and the Super EverDrive, and I usually use the EverDrive for development specifically because you can send ROMs over there. But it'd be really nice to have that for debugging too. Oh, it is implemented. That's awesome. I mean, to be honest, I haven't checked in like 3 years, but but that's really good to hear. Are you looking into developing for it? I feel like I have a lot of war stories about NuGet. But that I feel like, to be honest, that was mostly war stories with Visual Studio rather than NuGet itself. Also, a long time since I touched any of that. Bam. Oh, I like that. Oh, that's cool. Yeah, Super Nintendo, another system I want to do some more stuff on at some point. Eventually. Nice, Pyro. But yeah, it is going to be really cool to have like reading and writing memory on that working. Yeah, if Titan actually does something on SNES, I was really afraid they would for a couple years, but nothing ever happened. I talked to Jix at Evoke last year and showed him my setup, and he was kind of jealous of it and wanted to have it in Rust. It's in F#. So I think it'd be really funny if that's something that happened. If he made a system like the F# system that I have, but for Rust, I would just use his system at this point. But am I done? No, I'm nowhere close to done. Okay. Yeah, we gotta do the other sound states. Yeah, Sublime for the win, right? Okay, this stuff is gonna get less friendly. I'll do these ones by hand first. And then we'll do the multi-line edit on here. In fact, I can do these boys. Whoops. Dang it. That's just me getting impatient. Okay, I didn't do it quite how I wanted. Guess we gotta do this now. Dang it. That's okay, this should line up. Bam. Yeah, I gotta be honest, Colin, I don't like developing for SNES, which is why I did all that tooling in the first place. It's not particularly fun. But it's very powerful hardware, and I feel like it's still super untapped. I mean, even the stuff that I worked on, I just feel like could be a lot better. I mean, not to be too humble, I feel like it's like some of the best there is on the platform. But I feel like that says more about what's been like more about the untapped potential of the platform more than my stuff. Even just taking a bunch of ideas from like Amiga 500 demos and implementing them on the SNES, there's so much potential. It's just not fun to do. The next SNES demo I work on is going to very much leverage the tech that I already built. And I'm going to try really hard to do stuff that would be really, really hard to do with any other setup. Mostly just to capitalize on all that effort. So hopefully I get something interesting. I have some ideas I'm excited about, but we'll see. Yeah, I totally agree, Daniel Cullen. Need to do what Titan did and make something that's like way far ahead, and that just hasn't been done, I feel like. Okay, I want to do this. Oh no. There we go. I keep doing that. One too many. Yeah, SNES is just dripping with untapped potential. And I would love to work on that again at some point. Okay. But it'll be a while. There's actually not that much of this left already. This is great. That's awesome, Daniel Collin. I'm really excited to see it. Pyro says, did you program the SNES in ASM or C? I did it in assembler. I built a lot of tooling to keep me from writing too much code, but the code I did write was in assembler. And that covered both the SPC code and the CPU code. Is that it? That's the timer. I should run one of these. I also wrote the assembler we used, as well as the tool for making the music, and lots of other stuff. Not that there was any good reason for me to do that. It was just something that I wanted to do when I was really interested in how compilers worked and didn't have that much experience with it. And so I actually wrote that for the Game Boy demo that I did. And then later I made it support multiple architectures. And I did add some useful features. Like structs and namespaces. Just stuff that like make writing assembler a lot less shit. And I also took the approach that's taken by WLA, where you have a separate link step, which also really helps things. So there's sort of an object format. But if if I get back into that, I'll probably still use that assembler just so I don't have to remake anything, but I may end up at just porting that stuff to WLA. Yeah, thanks for sharing, Jared, too. Yeah, if you guys are interested in the setup that I'm talking about, that I'm referring to, it's all covered there. I don't think I explained it super well, but I'd be happy to try again, because that was really fun. A lot of pre-calc involved in the way that I did those demos. Oh, whoops, I forgot the comport thing here, didn't I? Oh yeah, I totally do have those streams, don't I, Drew, too? I keep forgetting all the streams I've done. I'm glad I have that stuff, you know? So I agree, Daniel Cullen. A lot of it's a lot of pre-calc and kind of like... I think that's probably the main thing I ended up learning through a lot of the old school stuff I've done, is just how much of it is data preparation. A lot of people have argued, in particular with the SNES stuff that I did, that it was cheating. Frankly, I disagree. I think it's one way to do it, and I think it was a cool way to do it. And I know a lot of other demos that use very similar techniques, if not the same techniques. And for basically the same reasons. Not that I feel like I have to defend myself at this point, because I think it was super fun, but I mean, just look at like the top C64 demos. And tell me there's nothing similar involved. Yeah, I called that tech the Mammon machine, because I'm obsessed with Chrono Trigger still. Do I want to clone the registers like this? Or do I want to copy them? I think I want to copy them. Thanks, Pyro. Yeah, to be fair, most of the people that were saying that stuff did not have, especially old school demos, to their names, I will point out. And the people that did, that I really respect, thought it was really cool, so... Yeah, Colin, if you look at lots of code, or if you look at lots of code, it's speed code with almost always LDA and STA. Yeah, it totally is. Totally is. And I mean, I think it's really cool, like especially with C64, you want to reduce like the solution I did on SNES definitely takes advantage of the fact that there's a lot of ROM that you can load very quickly. So it's okay to kind of have it that expanded, but in like C64 especially, you want to reduce bandwidth over the serial between the drive and the system, because you're going to be loading parts while like other parts are displayed. And so one of the things I think is really cool about those big on-world loops is you have like generators that are also written in 6502 that generate that kind of speed code before it's actually run in the effect. And I've only done a little bit of that myself in our C64 4K makeshift, but I thought that was really fun actually. You totally do it like you rely on like a macro assembler to just do it, dump it in memory initially, and then eventually when everything works and you get the layout all right, then you start porting it over to assembler itself. And I think that whole thing is really fun to do. Um, but it's also fun when you don't have to do it because it's a lot of work and sometimes it can be difficult. Even though the way that I ended up doing it, it wasn't just LDASTA. I mean, a lot of the times it isn't. It was like a block of code that I wanted to replace like two things in. So I had like a template, and then I would write in the replacements, and then I would just copy the template, um, however many times. Yeah, that's exactly it. I think that stuff is so cool. And at least especially the second SNES demo I did, like, I really don't think anyone can argue that that was cheating. The first one maybe because it was actually doing video decoding, using the DMA as sort of a part of a hardware decoder. But the second one, it was a lot more general, and that's the tech that I would definitely use moving forward with a couple extensions because there are some real-time effects. Like I want to do a polygon filler and a couple other things that we would definitely rely on CPU for. But yeah, that'll be fun to do some other time. What I wanted to look at here was this. Yeah, I want to clone this. Or copy the data, I mean, instead of clone it. That's a great statement to put with kappa face. The combination of Mode 7 and HDMA is really awesome. Yet at the same time, it's like, man, I wish I had a real copper. I think here I want to clone because I think the watch points are a map or something. It's a hash set, so for that I'm going to clone it. Yeah, the entries too. Because there's always the same amount of like cache entries. Also, these are clone and copy. So I should be able to copy from slice on these. Nice. And then, oops. Oh yeah, this is copying from the entries, or from the states, not the entries, so this of course won't work. Whoops. Can I zip? Because we know these are going to have the same sizes. I want to zip over both of these collections. But one of them's immutable and the other one's immutable. I mean, it's two other iterators, right? And then the type of those shouldn't matter. So if I did like the entries dot iter mute dot zip, loading here, and then the other iterator, like that. That should work. And then we should be able to do this. The same pattern here. Almost. And then I don't want to clone the subblock because the subblock valid is, I think, just a couple booleans. So this I can also do. Copy from slice, I think. Or I can just... how do I want to do this? Yes, a couple bools. Let's just do this. Can I do as slice here? It's a box slice. Really? Or it's a box with an array. A fixed size array. That? I'll take it if that works. No. Thanks, compiler, for telling me exactly what to do. That's also why I really like Rust. Great. That's the CPU. That's everything. Ha! I did not expect this to go this quickly. At all. So I'm just delighted right now. So now we really want to test like rewind and stuff. I'm going to pause my Rashadi B video game music covers, which is always what I listen to these days. And we're going to try some stuff. Particularly, I want to try rewinding. And it did not work. In fact, it crashed hard. Oh, great. So this is telling me that deserialization failed. It couldn't deserialize the state. There was a LZ4 error. Well, that's ass. There's so many reasons why this could be the case. So I think I'm going to try something else really quick, just in case. I think I want to just like try a save state not using rewind. I don't think it's going to make a difference. I think we're going to have problems in both because they should use the same mechanism. And then, yeah, exactly, Daniel Collin. That was exactly what I was thinking, is to remove the compression and just try to do it uncompressed, which should be really slow, but it should work, hopefully. Anyway, I want to save a state here. Oh, look at that flicker. Stupid. Save the state. and then we'll go like back into the menu, and then I'm going to restore that state. And it crashed. No idea why. This sucks, actually. State file already exists. Saving to backup buffer should be fine. Loading state, very different size. Loading state, saving state. And we got an unrecognized bit string op, which means something went wrong. Oh, that sucks. Okay, well then I'll try this without compression. Yeah, we could debug this. I could build a version of this with debug symbols, and we could even debug this with like Visual Studio. But I'm gonna try this uncompressed first, just because that was the errors that we got in the terminal, and I'm expecting, because like in this case it looked like it applied something. So there's like a whole class of errors that I don't think it is, with like weird pointers and stuff. So I'm not really sure how much debugging will help right now. No, Dan, I don't think it worked last time. It worked to save a state, and then when we restored it, we only restored like the workaround and stuff. So I don't think this ever actually worked. And in fact, even I remember last time I was playing with the rewind stuff, and I had the same errors. But then I decided to ignore it because I figured, well, we weren't applying the whole state anyway, so I didn't think that was a valid test. So it's probably the same issue, whatever it is, that we're seeing now. But I couldn't have known then. In any case, we have serialize and deserialize here. Actually, one thing I want to do here. I'm thinking I might commit this, even if it's buggy, because this would be a really good thing to not mess up or not lose. I'll do a squash me too. I want to push it because we're on a branch and we can force push. So we get the version state. And then this is something with capacity. Just some arbitrary number as far as I know. We build the encoder, and then we serialize into that encoder. So I guess this serializes into a writer. Is probably what's happening here. And then we finish with the encoder like this. I think what we can do here, the easiest thing to do is, is just get rid of the LZ4 encoding here and serialize straight into this encoded buffer here. And then, of course, this is not going to be relevant anymore. I think that will work if we make this mutable. Because I think Vex implement right, at least Vex of U8, so that's great. And then deserialize, we're not going to build the new decoder. And so we should be able to deserialize from this. I don't think these implement read, but I think if we build a cursor around it, I think we get what we need. If I'm right about the types. Or maybe this does implement read. Maybe a slice implements read. Or maybe deserialize from works on a slice. I don't know. Seems to be okay. I'm really excited to see this actually work. We need to get a new state now because the saved state from last time will not work with this. Also, rewind immediately didn't work. Crap. Really doesn't matter what kind of state we get to here. I don't remember the state slot, save state. State size a lot, and then here it's a lot less. This is kind of interesting too, because it says saving state and then loading it again. If we try to restore. No, that didn't work. It looks kind of like it's working, but we got some weird stuff over here. So nice thing is this is lining up here with this state size and then saving state here. And this is also the size that we had here. Yeah, that's so awesome that you did that, Drew, too. I still need to get me some of those glasses and try it myself. I have to do that. For a while, the earlier versions of Rush Boy had the red and the blue backwards. And I don't remember how I found that. How I realized that. I think I tried like the cross-eye trick, and then I noticed it was all backwards. I don't recall. In any case, this doesn't work. There's a couple things I actually want to try with this, though. I want to delete these save states just in case there's something dirty going on. But I have a feeling the problem is in my code. And the really crappy thing with this, I'm not entirely sure how to debug it. Yeah, this is a 16 meg save state. Shouldn't that have been like 18 megs? That seems smaller than I thought. Hey, Memoose. I mean, there is this that we don't serialize these entire vectors. That's probably what makes it smaller. Because that was something we did before. And particularly with the SRAM, that definitely could have made the difference here. Maybe. I'm thinking that the only way that this could have really failed, though, is if it went to apply the state and... Oh, wait a minute here. No, that's reading the state, yeah. And it just didn't apply something correctly. Or it didn't save or apply all of the state. So we're missing something, maybe? I don't really know of a way to debug that other than just starting to go through all the code again. Maybe I mean, the nice thing is this is all separated code. So if I want to just like bootstrap the emulator just enough to do this, yeah, that's kind of what I'm trying to avoid, Colin, is at least a lot of the validation code. But I'm thinking maybe if we serialize one of the states and then like run the emulator from scratch, like actually running a game, and then try to apply that state and then serialize that again, and we can check at least if the serialized ones match, because that would at least eliminate any errors that we might have in saving or applying the states. And then the error would be in something that's not covered by the states. In fact, wait a minute. I think we can temporarily just derive the equality traits for all the structures in the emulator. And then we could check those too. The only issue is that we need to make sure that we need to make sure that, what am I trying to say here? Like I need to run the emulator for a few seconds and then save out the state and then run the emulator for a different amount of time, reapply the state, and then check equality. But then I can also rely on those equality traits to do the round trip check. That doesn't seem so bad. Maybe that's how we debug this. And I just am looking at the time now, and I might want to do that next week. We'll try this one more time now that I deleted the save state. I don't think this will help. Whoops. Yeah, exactly. Force a reset and then reapply the state would, and then check for equality should totally work. In fact, we could just do that in the CLI version too. Relatively easily, I think. Because I want to check both those things in isolation. I want to check the round trip stuff in isolation, and I want to check the state apply stuff. Because we can also have it derive clone on everything, and so we can actually fork the state in memory and rely on that stuff. So we should be able to equality check those. I imagine there might be some of these that have state that we haven't encapsulated in the version stuff, but we shouldn't. I mean, there's like these pointers, which I should really get rid of anyway. Oh, hey. That could definitely be the problem. Because I don't reset this pointer. I end up... Wait. No. That's not the problem. Because I think... Yeah, I do copy from slice here. So that's going to copy the data, over the register data over this. So that wouldn't be the issue. And I don't think there's anywhere else where I'm doing that kind of pointer crap in the emulator now. Maybe there is. That would definitely explain why it crashes sometimes. But it didn't seem to crash from like memory access violations. It seemed to, or page faults. It seemed to crash from running invalid opcodes, like it read something wrong. I don't set the pointers again, but I don't replace any of the collections. I just replace the data. So the pointer should still be valid, and I think this is the only such pointer left. So, because that's what I was thinking, is that maybe the pointer would be wrong, but when I think about it, because of the fact I copy over this should be okay. Anyway, I didn't end up testing this. So I'll test it really quick. I don't expect it to work, and then we can look into debugging it next week, I think. I think that's what I want to do. But I'm already really pleased because I did not expect to make it through all that code today. I'll just do it here again. The save state here. So you see it plays this cutscene and everything. And then if I restore the states, yeah, load, and then we get this glitch again. So I'm guessing the CPU is doing weird stuff. Who knows what it's doing? But something is clearly not correct. At least these sizes matched up. We didn't get any errors in terms of like serializing or deserializing, so we'll keep the compression stuff commented out for now, and we'll get back to that once we know the other stuff is okay. Anyway, we'll do that next week, and then I expect if we debug it like we discussed, this should work out pretty well. So yeah, thanks guys for hanging out, and I will see you next time.